This short video is about the Cobb-Douglas production function, which is a very famous production function in economics. It is also known as the workhorse production function, and the reason is simple, because whenever we see the empirical literature, we find that most of the times it is used instead of any other production function form. There are other production functions, for example, constant elasticity of substitution production function, translog production function, variable elasticity of substitution production function, and so on. But whenever we open the empirical literature, we will find that Cobb-Douglas production function is more than 90% times used in it. So this is why we call it a workhorse production function. Now we have its history. It's basically forwarded by two people. One was Professor Paul Douglas and the other was Cobb. The role of Professor Paul Douglas was to find out, on the basis of the empirical observations, the properties of this kind of function, and the contribution of Cobb was to mathematically develop its form. So he was a mathematician as per his contribution. So what they did is to graph the capital stock and total labor force and GNP for the US manufacturing industry for the period 1899-1922. So they took this much of the data and they used this triad of the data, that is the GNP, the labor force and the capital stock, and they come up with this functional form in which output is a function of two inputs, that is V1 and V2, maybe capital and labor or any other. But in this case, Cobb-Douglas production function was originally for labor force and for capital stock. So their powers are there, alpha, 1 minus alpha. They are showing the output elasticity with respect to V1 and output elasticity with respect to V2, their powers. I have elaborated them now, so now they are much more visible and understood. The term A is the total factor productivity, which relates to the contribution into the output other than the contribution of this factor and that factor, because there are other factors that can affect the output. So that effect of other factors is captured by this term. It is known as the total factor productivity. So output elasticities, they have their own importance. They guide us about if V1 is contributing to a certain level, and what about V2. This can be updated with the help of beta. Here we have written alpha and here we have written 1 minus alpha. It is with the assumption that alpha plus beta is equal to 1, because in case of alpha plus beta is equal to 1, the value of beta will be 1 minus alpha. So instead of beta we have written 1 minus alpha, but in the background the assumption is alpha plus beta is equal to 1. It has an economic meaning, and that economic meaning is constant returns to scale, because when alpha and beta, that is the powers of the factors, they are summing up to 1, it means that constant returns to scale holds in this production function, which is an assumption of the Cobb-Douglas production function. Now in certain situations we are not necessarily confronted with two inputs. We can have other inputs like V1, V2, V3, V4 up to Vn. So we can generalize the Cobb-Douglas production function for those possibilities, that is V1 alpha, V2 beta, V3 delta, V4 lambda up to Vn omega. So we have generalized the Cobb-Douglas production function for n number of factors. So this was about the Cobb-Douglas production function, and in the next video we will learn about its isoquants and then further about its elasticity of substitution. Thank you.